Interpret cumulative frequency graphs. Let's first recap on what a cumulative frequency graph is. You start with a table which contains a frequency. Cumulative frequency is where we accumulate the frequencies. For the first one, we just write the frequency. For the second one, we add up the first two frequencies and write that. For the third one, you add up the first three frequencies and write that. For the fourth one, we add on that frequency to our running total. We keep going, adding on each frequency until we get a total of frequencies which adds up to the same amount as the total of the individual frequencies. To plot the frequencies, we use the upper bound of each class interval, and we plot that against the cumulative frequency. The cumulative frequency always goes on the y-axis. The variable x, the thing we are measuring, always goes on the x-axis. When plotting this, we should plot a nice smooth curve starting at 0. When interpreting a cumulative frequency graph, there are several things we need to be able to do. The first is to find the median. To find the median, we need to find the midpoint of the cumulative frequency. In this graph, the total of the data goes up to 120, so the median, the middle, will be 60. We go across until we hit our cumulative frequency line, and then read down to the x-axis to find the value. In this case, it is 325 hours. Other things we can interpret from a cumulative frequency graph include the quartiles. The median is the middle value, 50% of the data. The lower quartile is a quarter, 25%, so we halve again. Here that is 30. We go across until we hit our line and read down. In this case, that would be 275. To find the upper quartile, that is 75% of the data, we add onto the median another 30, as we know that is a quarter of the data spread, and we get 90. This is the upper quartile representing 75% of the data. We read across to the line and then down to see that this is 425. There are several other things we could be asked. We could be asked the number of light bulbs that had a lifetime of between 200 and 400 hours. To do that, we'd find 200 and 400 on the x-axis, go up to the line and across for both values, and read off the y-axis how many lie between those values. We can find out after how many hours 80% of the bulbs were dead. You'd find 80% on the y-axis, using the values you have already found, which would be 96. You read across and down, and that is 440 hours. What was the shortest lifetime of a bulb? We need to look at where the cumulative frequency graph starts, and that is at 100 hours. So that is the shortest lifetime of a bulb. Teaching techniques. I start to teach this topic by getting students to plot a cumulative frequency graph. Once they've done that, we can discuss where to find the median. I always link the median to 50% of the data. On this graph, we'd see that as the data goes up to 40, 50% of 40 is 20. We'd find 20 on the cumulative frequency y-axis. Never use the x-axis. This is a common mistake that students make. We go across until we hit the line and then read down to the x-axis, and that gives us 3.2 hours for the median. You should encourage your students to draw on the graph itself, as it shows evidence that they have used the graph itself to find their answers. To find the lower quartile, we are looking for 25% of the data. I always say that a quartile is a quarter, and that is 25%. We are looking for 25% of 40, which is 10. Again, we go across to the line and down and read off the value. Here it is 2.4 hours. The upper quartile is the third quarter. Think of this as 1, 2, 3, 4 quarters. The third quarter is 75%, and that is 30. We draw a line across to the line and down using a ruler and see that it is 3.89 hours. Here I would link in the interquartile range. We need to find the lower quartile and subtract it from the upper quartile. Here we have 3.8 minus 2.4, giving an interquartile range of 1.4 hours. I explained that the interquartile range is the middle 50% of the data. The median is a measure of average, and the interquartile range is a measure of consistency or spread of the data. I would also mention that sometimes, although the scale on the graph may extend beyond the data, students are always looking for the spread of data represented in the graph, not the graph itself. When finding the median, students have to look at the spread of the data and not the limits of the scale on the graph. Deep thinking. Bianca says the median is 200. Why is she wrong? The median is 50% of the data, and we can see that the data goes up to 1000. 50% of 1000 is 500. We need to find 500 on the cumulative frequency on the y-axis. Then we draw a line across to the curve and then down to the x-axis. The answer is 65, not 200. What Bianca has done is a common mistake. She found the middle of the data on the x-axis and then read off the y-axis, giving her answer of 200. To address this, you need to explain the context of what you are doing. The answer will be a score, so you can't start on the x-axis. If you start on the x-axis, your answer will be from the cumulative frequency, which is a total of the number of scores and not a score itself.